Hi, in this figure, it shows us a tank within a tank, each containing air. The absolute pressure in tank A is 267.7 kilopascal. Pressure gauge A is located inside tank B and reads 140 kilopascal. The U-tube manometer connected to tank B contains mercury. Using data on the diagram, determine the absolute pressure inside tank B in kilopascal and the column length L in centimeter. The atmospheric pressure surrounding tank B is 101 kilopascal. The acceleration of gravity is 9.8 meter per second squared. What is given to us is tank A inside tank B, both contain air. The absolute pressure of tank A, the pressure gauge reads 140 kilopascal. Tank B is connected to a U-tube manometer. The fluid of it is mercury. It's very important to keep consistent units. So we are dealing with meter per second squared. We're meeting with Pascal, which is Newton per meter per second squared. So that's why we had to convert the gram per centimeter per cubic centimeter by using these two factors to give us kilogram per cubic meter. We are giving the atmospheric pressure as 101 kilopascal and the acceleration due to gravity. So we have here the pressure gauge connected to tank A and the U-tube manometer connected to tank B. This figure will help us determine the absolute pressure inside tank B. As you can see, here we have the pressure gauge. The pressure gauge is the difference between the absolute pressure and the atmospheric pressure. Now, in our case, the atmospheric pressure is the outside temperature, which represents tank B. And the B absolute here represents tank A. So to find, so that means the pressure gauge A equals to absolute pressure of tank A minus the absolute pressure of tank B. The pressure gauge that is connected to tank A inside tank B reads 140 kilopascal. The absolute pressure of tank A is given as 267.7 kilopascal, and we need to find the absolute pressure of tank B. We move the 267.7 to the other side of the equation and we change the sign. We add these two numbers. Both sides of the equation have negative, so we can cancel it. So we end up with the absolute pressure inside tank B is 127.7 kilopascal. In this equation, so since we are since we have found the absolute pressure inside tank B, that means that the absolute pressure inside tank B exert a force on the mercury fluid in the U-tube manometer. So as the pressure of tank B increases, the length will definitely increase. In fluids at the same depth, we have the same pressure. So if we know the pressure in this side, that means we know the pressure on this side and vice versa. So to find the pressure in this side, we need to add the atmospheric pressure, which is exerting pressure on the mercury fluid, and the mercury fluid is exerting that pressure on this point by using the pressure equation rho GL. So we need to determine the column length L in U-tube manometer. We use this equation. We already know the absolute pressure of tank B to be 127.7 kilopascal. We're giving the atmospheric pressure. We are giving the density and the gravity. we multiply the density times the gravity, and we combine the units. As you can see, the meter cancel with one of the 3 meters in here, so we are left with meter squared. So we have kilogram, meter squared, second squared. As a side note here, Pascal is a unit of Newton per meter squared. Newton is mass times acceleration, so kilogram times meter squared divided by meter per second squared divided by meter squared. So we replace the Pascal with this unit, and we remove the kilopascal by multiplying it by 1000. So instead of 127.7, it become 127,700. We move the 101,000 to the other side of the equation and change the sign. We add these two numbers, and we solve now for length L. So here we are solving for length L, but we need to make sure that we have the correct units. So what we did is the kilogram times meter per second square. The meter square, since it was in division, it will go to the top, and it will be in by multiplication, and the sign on the exponent will change from positive to negative, as we can see here. And similarly, since this was in division, it will go to the top, multiplication, and since it was in division, it will flip. Whatever is in denominator will be in the numerator, and whatever is in denominator will be in the denominator. So we did the multiplication, we flip, and now we make sure that we end up with meter. So what happened? The kilogram cancel with kilogram, second square will cancel with the second squared. Exponents in multiplication, we add them, so 1 plus minus 2 will end up with m minus 1, and we have m2. As we said, the kilogram cancel, the second square cancel, so we're left with meter. So the exponent minus 1 plus 1 will give us meter to the power 1, so we will be given so our units are correct. So the length of the mercury is 0.2 meter. We use the conversion factor because we are asked to find in centimeters squared, so it will be 20 centimeters square. I hope you find this helpful. Thank you very much for watching, and have a good day.